Here we have a couple of expressions involving square roots that are not the prettiest, and we want to simplify them. We also notice that in all cases, none of the numbers underneath the radical are in our list of perfect squares, which is a shame, because these are the only numbers that we could actually square root and get what I call a pretty answer. So what we are going to do is look at this list, look at the number we're being asked to square root, and see if any of the numbers up here will divide this evenly. The reason why we're going to do that is because of this property down here. There's a property of square roots that says if you have two things multiplied together and you square root them, then it's the same thing as taking the square root of one times the square root of the other. Another way to think about this is that you can break up square roots over multiplication. So I'm going to try to find the biggest number that I can square root that goes into 72, and then I'm going to break up the product and square root the part that I can. We're always looking to square root one of these. So the trick is to find one of these that divides that evenly. And the best thing to always do is you want to start high and work low. So for example, 81 is not going to divide 72. It's obviously too big. 64 also won't go into 72. I'm pretty sure 49 won't go into 72, but in case I wasn't sure, I can bust my calculator out and I can see what 72 divided by 49 is. And if it's a nice, pretty number, then it goes in evenly. This is not, so I can't use that. But I'll try the 36. Again, I'm not sure if it goes in evenly, so I'll see what I can do. Looks like it goes in 2 times. So I'll rewrite that 72 as the product of the biggest perfect square I could find that goes into 72 evenly and whatever's left. Then I'm going to break it up over multiplication. And this is a number that I do know how to square root. I know the square root of 36 is 6. I don't know the square root of 2, so that's going to stay. This is called a simplified version of root 72. There's ways to verify your work using your calculator, like you can compare the square root of 72 to 6 times the square root of 2. Whoopsie doodle. And you'll see that you get the same exact answer. For a problem like this, we're going to use the exact same property but in reverse. We have this side, we want to make it simpler. So if I have two things that are being multiplied together, I am allowed to put that square root over the whole thing, which gives me the square root of 50. But I'm not done yet. I got to see if I can simplify this. So I'm going to go back up to my list and try to find the biggest one of these perfect squares that goes into 50 evenly. Start high, work low. So obviously 36 is not going to work. 25 for sure. 50 is 25 times 2. Now I'll break it up again as root 25 times root 2. That's terrible. Root 25 times root 2. And I'm going to square root the part that I can. The square root of 25 is 5. Square root of 2, I don't know what that is, so I'll leave that as root 2. That's my answer there. So as long as we're trying to find these perfect square factors and breaking up or combining things over products as it says down here, this is going to go pretty smoothly. Definitely I would recommend writing this list of numbers at the top of your paper for the first 2,000 times you do these problems. Good luck.